Hello, in this video we're going to be talking through how to interpret the actual results of the standard multiple linear regression that we performed. So we know from the previous video that there weren't any concerning violations of any of the assumptions, so we can kind of proceed. The only assumption that we weren't sure of was about the independence of error, and we took through some potential options for handling that, including mean centering the variables. But in this instance we're going to talk through the results of the regression from using the raw untransformed data. But it may be something that you look at doing if this was your own piece of research. So if we come back to our output file, so we can see, if I make that bigger, we have looked through things like the correlations and to get a sense of what's going on. But the first box we'll just double check is the variables entered or removed, and we can see that the method we used is the enter method, which is SPSS speak for the default, which is the standard approach. So we've used the standard linear regression where we've put our three predictor variables in all at the same time to explore how they help us understand our dependent variable, which is the cognitive well-being mean score. So the first thing we want to look at is in the model summary. This gives us an idea of how well our model fits the data. So it gives us an idea of how accurate our predictions based on our model or regression model are likely to be. Now what we can see here is that we've got the an R-squared value and an adjusted R-squared value. So if we just want to talk about our sample, we could interpret the R-squared. If we wanted to be extra cautious, we could, and we want to make generalizations more about the population our sample was drawn from, then we can use the adjusted R-squared. You can see there is a bit of a jump between the two, two values, but not too substantial, so it's not too concerning. What is concerning is that actually if we multiply that by 100, the percentage of variance that our model, the three predictors together, can explain in cognitive well-being mean score variance is tiny. So if we multiply that by 100, it suggests that our model can only account for 2.5% of the variance in cognitive well-being scores. So that's not a good start for the model. It suggests that actually there's probably an awful lot of other things that influence cognitive well-being, and that actually we might be able to use to predict cognitive well-being better than materialistic aspiration, attainment and importance scores and a person's gender. So the next thing we would look at is the statistical significance of the model. So if our model overall is statistically significant, it means that it's better than just using the mean of the outcome score, guessing someone's score on cognitive well-being. And what we're looking for is that value in the significance column is 0.05 or smaller. And we can see that it's not. It's actually over 0.05. This suggests that overall our model is not statistically significant. So it's essentially not better than just guessing someone's cognitive well-being score. So that's not a good sign. It's not that it necessarily means if you have non-significant results, when I say it's not a good sign, if you're reporting it, you would look at all of the reasons why you might find this, and actually sometimes a non-significant result can be really illuminating, that if all of the literature suggests that we should be seeing that these things predict cognitive well-being, then we can think about why is that not the case. Perhaps it's the way that we've explored it and we've measured it. We checked all the data assumptions, so it's not that we're using an inappropriate test. It could be something to do with sample size, so we'd have to be clear about, did we have enough data to detect, a reasonably sized effect if one existed. So there are things like that to consider. What would happen now normally is that you would report these, and you would report a table of the coefficients for the individual predictors so that someone can see all of that. But we normally wouldn't interpret the relationships between these predictors, because whatever we identify could be spurious. So one of the things might be, if we're thinking that it may be about power, it's unlikely, but it could be, that we may make the argument that actually then we'd rerun the analysis and we would chop out the predictors that don't seem to be doing anything, and see if, for example, if gender on its own predicts the cognitive well-being mean score. The argument with that, against that, is that that might be a little bit like fishing, but it could be that you've got a good reason to do that. So you still want to look at the impact of gender on its own, for example, or cognitive well-being or materialistic aspirations on its own, but you'd have to be clear as to why you would do that. What we can see is that, as I said, you would report this, but then conclude that basically you haven't found support for your hypotheses, because, and then talk about what the potential reasons for that are. For the sake of illustrating how you interpret the coefficients, I'll talk through that now, just so you get a sense of it. So, for example, if we'll look at the continuous variables first. We've got our unstandardized coefficients, which are represent the original units of measurement, and we have our standardized coefficients, which are in standard units, and we can compare between to see which is the strongest predictor, and so on. So on our unstandardized coefficients, if you think back to your the regression lecture, we know that it suggests that for every unit on materialistic aspiration importance, we on that scale we go up. For every point we go up on that scale, we'd expect cognitive well-being to go down by 0.04 of a point on the cognitive well-being scale. In contrast with the materialistic aspiration attainment mean score, for every point we go up on that subscale, we would expect our cognitive well-being score to increase by 0.1 of a point. So we're seeing that that's a negative relationship, that's a positive relationship. If we cast our mind back to how we interpret a dichotomous predictor with regression, and if you're struggling to do that, then look back at that regression lecture. We have to remember how we scored our variables. So if we have a look back at our data set, what we'd see is that males were scored in our data set as 1, or coded as 1, and females were coded as 2. So that's how the original authors coded their data. I tend to use 0 and 1 because I find it easier to remember. But what that means is that whatever was coded as 2, in this case female, score higher than whatever was coded as 1, which was male. So they're scoring higher because that value is positive. And in fact, they're scoring 0.3 points of a point on the cognitive well-being score higher than males. And so that's kind of how you might interpret those. If we wanted to kind of go a bit further, again, if this was statistically significant, then what we would do is look at our part correlations, and we would square that value to start with, then multiply it by 100, and that would give us the unique percentage of variance accounted for by that predictor after we've controlled for the other two in the model. So that again would be a useful thing to include in a table, even if it's not statistically significant. Actually, including it in the table would make sense. But what we can't do, because our overall model isn't statistically significant, is put any weight on these patterns of findings, really, because they could purely be spurious. So although sex on its own looks like it's a unique predictor, that could be a spurious result, because overall it suggests our model isn't statistically significant. But hopefully that's given you a sense of how you might interpret that, and how you could probe your relationships more if you did have statistically significant results. And hopefully that's been useful. So what we'll do now is, in the final video, is just kind of bring a few things together to talk about general guidance for reporting. Don't forget as well that there are more specific guidance in each of the lectures for ANOVA, MANOVA, regression of factor analysis for reporting, and that you can look back at those as well. Okay, so thank you.